Hey everyone, it's David with Streaming Relativity, home of the AstroDNA Observatory. You know, I've had some really good seeing this past week, and I decided to take advantage of it and do some final imaging with the Celestron C8 before I bench it at the end of the month. And for those of you who are not familiar with the Celestron C8, the C8 is an iconic telescope. It's a 8-inch aperture, or 203.2 millimeter aperture Schmidt-Cassegrain telescope. And I use it with the Celestron 6.3 focal reducer. So I achieve about 1280 millimeters of focal length. And I'll tell you, that's a lot of light gathering capability on a relatively small patch of sky. And if you point the telescope into the right regions, you can capture some amazing images. And I'm talking specifically about galaxy groupings. And I was looking at the constellations of Pegasus and Perseus. In fact, I imaged over 50 galaxies, and I time traveled hundreds of millions of years into the past, all in one night using my C8 telescope. And, you know, imaging galaxies in groups is so profound, not just because each of the many galaxies in a single frame contains billions of stars like our sun, but in fact, these galaxies are, in many cases, wildly different distances from the Earth. So your rig actually becomes like a time machine, and you're able to capture photons, some of which have traveled for, say, hundreds of years in the local star fields. But in other cases, these photons have traveled for perhaps as much as 1 billion years. And all of that is being captured into one image. And it's absolutely amazing. So if you're ever in need of perspective, get your telescope out and focus on some of the targets like the ones I'm going to share in this video. And of course, if you're new to, if you're into astronomy and all things astrophotography, and you're new to the channel, I've got tons of content to share. So go ahead, subscribe, and get notified. And with that, let's jump back in time to December 8th, 2023. I had a really brilliant stretch of viewing in the last 10 days or so. So a lot of time is being spent on gathering data, and that's actually really important. When you know you're going to have good viewing conditions, you should be organized and should take full advantage of that time, you know, to gather the data that you're looking to gather. And knowing that my C8 is getting benched, I don't intend to use a C8 during the winter. I actually intend to move to a new telescope rig that I set up several months ago that I haven't had a chance to deploy, which is the Astrotech AT115 EDT, a triplet. And it's going to be a lot of fun, and I'll obviously cover this in a series of videos when I get that up and running. In the meantime, we're going to take advantage of the C8 while we can, and I wanted to focus on distant galaxies. You know, I graduated college a year before Hubble was launched in 1990, and as a child I was always interested and fascinated with astronomy. And then with my engineering studies, I studied electrical engineering, engineering physics, computer science. I was in awe by what Hubble was able to do and deliver to us. And one of the most famous pictures, or a series of pictures and mosaics that came from Hubble was an image of thousands of galaxies, distant galaxies in full color. And you know, I was always able to comprehend theoretically the scale of the universe and the physics of the universe, but until those images came from Hubble, I wasn't able to really appreciate it. And if you don't own books, you should. But in particular, I'm talking about Hubble's Universe. This is Terence Dickinson, a wonderful book full of amazing photographs captured by Hubble with lots of background information. And so I'm talking about the place where there are hundreds, if not thousands, of galaxies, very distant, captured by this wonderful instrument. And I wanted to do the same with the C8. I wanted to take full advantage of the aperture and the focal length. Obviously, we're not going to be able to capture galaxies that are 12 billion light years away, but wouldn't it be great if we can capture galaxies in a field that are perhaps several hundred million or even a billion years away? And that is absolutely possible with the C8. So I knew that I wanted to focus on the constellation, the areas of Pegasus and Perseus. And today I'm going to talk about specifically what I imaged in Pegasus. And I chose a grouping called the Deer Lick. And this is not a gravitationally bound system of galaxies, rather it's just a visual grouping of 5 galaxies. And I chose it because the field of view of the C8 with the focal reducer also allowed me to capture a number of other galaxies and kind of get this Hubble-esque capture. So the Deer Lick group, central to the Deer Lick group, is NGC 7331. And 7331 is about 45 million light years away, and it's actually considered our twin. If we were able to look at the Milky Way ourselves, our own galaxy, we would expect to see something like NGC 7331. For that reason, it's a very fascinating galaxy to image. In fact, when you refer to Pegasus and some of the features of Pegasus, I happen to use Burnham's Celestial Handbook. You'll see that NGC 7331, as it was imaged by a 200-inch telescope back in, I guess this was done probably in 1970s. And interestingly enough, that same image was used as inspiration for an artistic rendition of the Milky Way in this Cosmos book, which is Giles Sparrow. And so this is an artistic rendition of what the Milky Way would look like, and I think it was largely inspired by what we see in NGC 7331. So I thought this was going to be a fascinating topic, and one last piece of reference, as you can tell, I'm an old school astronomer, but I'm going to refer to a sky chart, one of the early sky charts that I purchased. In fact, I bought this sky chart, which is a series of 16 plates. I bought this sky chart back in 2008 for $15, and I can't tell you how happy I am with that acquisition. So at any rate, we know that NGC 7031 is in Pegasus, and we can go ahead and take a look which chart plate where we would be able to find NGC 7331. And in this case, there's a chart plate guide on the back of the cover sheet. And so plate number 5 covers an area of the sky with a declination of 20 degrees north to 65 degrees north. And given that NGC 7331 is right around 35 degrees north, a little bit less. And then the right ascension hours of 18 hours to 24 hours, and given that NGC 7331 is around 22 hours and 34 minutes in that neighborhood, we know that plate 5 is what we want to refer to. So if we look at plate 5, we see should see, right away I can see Andromeda, and then I know the NG, let's take a look here, 2234, up, bingo. So 7331 is on this sky chart, but none of the four galaxies that surround it in the background are represented on this chart, because this chart only goes up to a magnitude of 13. And we will be looking at galaxies that go down to a magnitude 16, and maybe even 17. Okay, so yeah, I'm pretty old school. I enjoy my printed material, but I'm pretty tech savvy as well. And I have to tell you that planetarium software like Stellarium and Sky Safari, they're deeply integrated into my workflow. Here we can see a Stellarium is open and running through a speeded simulation of NGC 7331. Speeding through the sky from about 6:20 p.m. Down to roughly, let's just, we'll call it midnight before it starts to get out of view. So that gives us plenty of time for LRGB imaging. Okay, we're going to go ahead and we've brought up the NGC 7331 in our planetarium software, which happens to be Stellarium on my Observatory computer. I'm remote desktoping into that computer. So what we're going to do is go to framing, and we're going to pull in those coordinates. It's the Deerlick group of galaxies, and this is in Pegasus. So again, it's only around 5:24 p.m. It's a little bit early to be doing this, but I'd like to go ahead and see if we can't get a test frame here. And so we'll slew out to that target, and we'll grab a frame. All right, so we are within our tolerances. Let's go ahead and let's get a exposure here. Okay, so we've got a galaxy, that's for sure. And you can actually start to see some of the other galaxies. Okay, let's freeze frame right there and take a look at the statistics. We're noticing that I shot luminance filter for 60 seconds, and we had mean ADU values of around 2100, which is about double what I usually target for LRGB image sessions. And with that information, I have everything I need to know to actually set up the sequence. Okay, so I'm going to go ahead and show you how I typically set up a NINA sequence for one of my targets. We've already gone through Stellarium and importing that target into NINA, but then we need to add it to a sequence. And so we're going to add it to the Deep Sky instruction set, the DSO instruction set. So this is very, very convenient. So all the operations instructions that I now issue within this group will apply to this target and its location. So I typically, if I'm going to make a change, since I store my data in a organized manner, if I'm going to make a change to how I want to refer to this data in my system, I will do it here. In this case, I actually do. I change it to NGC 7331. And then from there, we're going to add a set of instructions. And usually what I'll do is I'll set up a global trigger right away for autofocus after every filter change. And then within the DSO instruction group, I'll add the first instruction, which is a telescope instruction to slew and center the target. And then I'll run and I'll do a bunch of exposures, smart exposures, and these are camera instructions. And there's a smart exposure option, and I like to shoot 60 frames of luminance, and at 30 seconds to get me the target mean ADU of roughly 1,000 or so, up to 1,200. And in this case, I'm going to dither every 5 frames. Sometimes I do 3, but I find 5 has been working well for me. And I just noticed right now that my I recently did some narrowband work, so my default setting for the camera is off. It's actually reflecting what I would normally do for some narrowband imaging. So we're going to reset this to 139.21, which is unity gain for the ASI 1600, and I think works really very well. So that is now reflected here. In terms of from there, I copy over. From there, I copy over the values for the smart exposure. I change my filters to R, and I quadruple the amount of time for the RGB filters, which gets me to an ADU typically around 900 for the color filters, which is absolutely perfect. And if I copy that over several times, and the difference is that for the purposes of the sequence that I ran on the 8th for this target, I did not run 60 exposures. I didn't have time. I had a shorter window. If you remember, we had about 4 hours of time. So we're going to run these 30 exposures each, and that gives us an hour each of RGB plus a half hour of luminance data. Obviously, we'll go ahead and we'll do the filter changes here. So R, G, and B. And then I'll just, sometimes depending on the exposure, number of exposures and the length and total exposure time per filter, I sometimes like to add an instruction which is to re-slew and center, the telescope in between filter changes. I do this usually if I'm over 2 hours or over in terms of a smart exposure duration. I just find that this accommodates correction for any drift that sometimes takes place over the course of a long sequence. So that is an optional step here that I'm just showing you that I follow. And then obviously, finally I have a ending sequence instruction, a sequential instruction set that that I use to shut down the dome and set the scope to its home position. So you find home on the telescope, find dome home, and then you close the dome shutter. And that is basically the template LRGB sequence that I use for these types of deep sky objects. Okay, let's peek at some random subs. This is 1/32 luminance frame. This is 1/122 red frame. Green frame, 120 seconds. And blue frame, 120 seconds. Okay, and now the stacked images. This is luminance stacked. This is red stacked. This is green stacked, and this is blue stacked. And look at the drift that we see throughout this sequence over roughly a 4-hour period. The key here is that across all of the across all the stacks, we are seeing some faint galaxies, and lo and behold, we're seeing faint galaxies throughout the frame, even beyond the 5 that make up the Dirichlet grouping. We see galaxies everywhere, and then later on you'll see as we process this, we actually have some really cool things to explore here. Okay, and of course, for those who follow the channel, I use PixInsight, and I have a very simple workflow for my LRGB images. I break up my project into multiple workspaces. I take my raw files. I get them aligned and cropped, and I do some linear fits, and I usually denoise at this stage as well to get relatively clean channels. And then I bring those channels into my stretching workspace where I stretch the fit denoised images. Here we see the luminance, we see blue channel, we see the green channel, and we see the R channel. And from there, I'll do my first color study. I use a very simple LRGB combination tool, and maybe a little bit of playing around with curves to get the color balance where I want it. And then in this case, I actually wound up adding some annotations to the image. And with that, we're going to take a look at the image and see exactly what this C8 was able to capture. Okay, so let's have a little bit of fun with this image, which I happen to absolutely love. I love how this image came out. And it was a relatively easy processing, and but it has such a wow factor about it. And at least it does for me, and what it represents, and we'll go through all of it, and hopefully you'll enjoy this. But let me start with the central feature of the photograph, which of course is NGC 7331. And remember, earlier in the video, I mentioned that this is often referred to as our twin, which means that this is a galaxy that's, let's call it 100,000 light years in diameter, and that somewhere maybe 25,000 light years away from the core sits a sun just like ours, perhaps, and because that's where we sit relative to the Milky Way galaxy. But I absolutely love some of the details that are picked up in this photo about about this galaxy, which is about 45 million light years away. Absolutely, stunning in my opinion, and just very happy with it. And then we have surrounding that, we have 4 other galaxies of different types and shape, including this barred galaxy. Looks like a spiral, and a galaxy as well. But these galaxies are as much as 365 million light years away. That's why I said originally that these are not gravitationally bound galaxies. This is just a photographic grouping of them, and I think it's stunning. And this is, if you can think of this galaxy, it is the closest, 45 million light years away. These are more distant galaxies in the background, and just sets up for such a nice photograph. And in fact, if we look around, we see other galaxies in the photo, and they are really impressive. So what I decided to do was annotate this image, and so let's take a look at the annotated image and see what we're looking at. Okay, so first things first, each of the galaxies in the Deerlick group, NGC 73, 37, 35, 36, 40, 38, and then 33, of course, over here. Oh, I apologize. 38 is not. This is a double star. This is a double star system in Pegasus. But as we kind of zoom out and look in other areas here, we see these much smaller galaxies, PGC 204, 58, 49. All of these are definitely galaxies to look up and to read up on. There's not often a lot of data other than to indicate, their suspected distance and the type and shape of the galaxy. But this, for me, is very Hubble-esque. And for a C8 telescope in a backyard observatory to be able to capture this piece of history, because the light that makes up this frame has traveled for hundreds of millions of years in some cases, to reach that sensor. And for 3.5 hours, we captured that data and produced something really awesome. I want to turn our attention to something over here that I couldn't figure out what this was. I'm surprised it wasn't labeled, because it does kind of look to me like an edge, almost like an edge-on galaxy, but it's not. Or at least it's not being recognized by any of the plate solving software. So I went out and I checked an AstroBin for others who have imaged 7331, and lo and behold, I see it in other images. So this is something, and I haven't had enough time to kind of research what it is exactly, but it is something that I have seen in a number of photographs, and I'd love to understand what that is. If you know what it is, go ahead and leave it in the comments below. But at any rate, this is the net result of about 3.5 hours, 4 hours of data, very simple processing with a Celestron C8 and the iOptron CEM 120 mount. And I think it's a wonderful image to to end the year on it. Even though it's not the last image I'll do with the C8, it's one of the last ones that I'll be doing with the C8 this year. In fact, I have data for 3 other phenomenal targets that I gathered with the C8 over the last call it 10 days. And I'll be processing that data and sharing it on the channel over the holidays. So I hope you enjoyed this, guys. Okay, folks, with that, I'm going to call it a wrap so I can get to work on some of the other data that I've collected with the C8. And maybe I'll leave you with a little bit of a teaser. We're going to be looking at NGC 1275 in the constellation Perseus. And I actually got a phenomenal two nights of data on the Bubble Nebula. And so we're gonna do a video on the Bubble Nebula, and that will be the last image with the C8 for 2023. So thanks so much. If you like this and you want to get notified about those videos, subscribe, and I'll see you on the next video.